Let's talk about non-functional testing. What is this? What is non-functional testing is? In simple, all non-functional testing answer to question how. How many transactions can be processed? How fast can they be processed? And talking about failover and recovery, we should define that resiliency is. We call system resilient if it's able to recover and continue working after failure of one or more of its components. Why resiliency is so important? Speaking about market infrastructures, outage of such system is associated with following risks for business. Lost profit because the system doesn't generate any profit, then it's down. We can also lose some of data what was processed at the time of outage, and that's more important because of that we can lose consistency across market data. So that two different market agents would see different picture of market, which is unacceptable for us. And last but not least is damage reputation, which is super important in the world of finance, because when market value goes down, a lot of tweets, angry reports and articles arise immediately, and the whole world knows about your failure. Before we start talking about failovers, I would like to give you a deeper understanding what market infrastructure system is. Usually it's distributed computer system with dozens or hundreds of servers connected via a local network. Each server hosts one or more processes. Such systems are scalable and run on bare metal servers. We are working in the production-like environment, and we can't install all required libraries due to signed-off list of packages, and no one wants to take responsibility when there is a tiny chance of a system's misbehavior in comparison with production. And the most interesting feature of distributed system from resiliency point of view is redundancy. Redundancy means that each component, or at least each critical component of the system, is duplicated. In other words, there are primary and secondary instances for each process. Usually we call secondary instance a replica or standby. What can go wrong with a distributed system? For example, we have a system without bugs, but in case the hardware is going to fail someday, statistics say that 90% of hardware failures happen due to problem with hard drive. Since we can go into the data center and hit some hard drives with a hammer, we need to simulate a malfunctioning hard drive as well as other hardware. For this purpose, we are using SIG-stop and SIG-kill Unix signals. They both are especially good because they cannot be blocked by process. So each process in our system has a standby, and there are usually 4 cases to test. First case, everything goes as expected. Primary is active and standby is passive, and when primary goes down, we call it failover. We need to check that standby became active and continue to process all transactions. You can see original and failover state on 2 left pictures. Another thing what we would like to check, if it's possible to get back to primary if active standby goes down, and we call it failback. Third thing is to test that outage of passive component doesn't affect the system. And fourth, it's double fail. Then both instances are down. We need to check that the system is recoverable after double failover. Sorry. Yeah. Okay. What kind of data we are collecting during our tests? There are 3 main points. Before testing activity start, we need to backup all the databases and configuration files, make a system snapshot like running processes, system component version, and so on to have all preconditions recorded. We have to rely on our own to prove that two test runs are comparable with each other. The second point that non-functional testing means that we are working with automated scenarios. We use our internal tool called Test Manager, which is responsible for test scenarios execution. We are reacting on system events in real time to decide. Then we can proceed with our tests. Test data is the main value for us, and we can run our tests around the clock, but our human resources will be involved in test improvements and results analysis, bottom test execution. And at the end, we upload output from Test Manager along with system logs into our test database. And here is how we look when we collect lots of data, but we not automated our analysis. What do we do with data? Sometimes we have obvious bugs, then some components got crashed or system became unresponsive, but usually it's not simple to identify a bug in collecting data. And for analysis, it's easier to deal with numbers. So we collect our data and convert it into metrics. Let's look at some of them. From system statistics, we can get disk, RAM, and CPU usage metrics. From captured traffic, we match each request versus its response and calculate latency. And by looking at logs, we build entries, warnings, and errors per second metrics. And talking about black box testing, we never know what we can find in logs, so we also check them for alarming patterns using regular expressions. Okay, here we are. Executed thousands of tests, collected gigabytes of data and thousands of metrics. What do we do now? The easiest way to identify an abnormal behavior is to use thresholds that trigger alerts, like in this example. Usually, such memory growth means that there is a memory leak, and thresholds like this help us to detect them. Then we report the incident to developer, and they search for a memory leak. Let's take a look at this example. Other than growing, metrics sometimes show spikes like this. For example, action in our scenario may cause response time spike. To identify spikes in our data, we use different techniques like moving average. For each new metric, we calculate moving average, and if new value has moved too far away from the moving average, then we raise an alert. On this slide, we can see CPU usage spike happened at 11:49. Most likely, this spike is due to last executed action in the scenario. The incident will be reflected in the report, but such anomalies are not always bug actually. For example, then some component is down, some hour is going to take its calculation, and it is expected that an hour component can increase resource consumption after failover. We write exceptions for situations then we don't want to trigger an alert because of spikes like it. It's important to be sure that collected data are consistent because some transaction can be lost or duplicated during failover. Also, we are checking that data received by clients via direct connection are consistent with broadcasted market data. And one more check, it is the consistency of transactions between internal database and captured traffic. We need to get system metrics in real time for active testings. There are several options. We can use system tools such as IO tools, NetStart, and our. But we are on the client side, and we can't rely on such tools. And sometimes a software vendor provides the monitoring tools which are used in production, but usually it's not designed for testing. Those tools may not display some metrics which can be useful by an operator, but it can be used for testing. This data can be platform-specific, need a graphic interface, and have no API for interact with. Even if all the conditions are met, we have to create a wrapper for every monitoring tool to use its data for automatic testing. And the best option here is using popular third-party monitoring. This list is what we want to have in our data collection tool. The monitoring tool must be platform independent. Say a statically compiled binary which should cover all our monitoring needs. We also want to manage configs in real time, so every monitoring daemon must be able to track different things at different times for a particular test to minimize a footprint. For example, we need to parse logs in real time because we can't capture and decode internal system messages directly. And parsing thousands of metrics from logs in real time is overhead. We also need to get data from daemons easily using monitoring and our test tool. So the support of different formats is required. Some test scripts need to track different things, so our daemons should have a split data flows for different clients. For example, Grafana has to receive hardware statistics only, but not some internal metrics which are required for active testing only at the moment. Different clients are able to subscribe to different data channels and receive the required data only. Since we are using our own monitoring, the data is uniform across all our environments, and there is no need to adopt test script to work with different data formats. Of course, it looks like a bad idea to support an our tool which is unlikely to be used outside the company because it solves only our own problems. The green code is not well tested in comparison with popular community solution and can consume a lot of time for solving bugs, but not exact problems. Okay. As you know, different tests require different metrics. Exchange system operate with thousands of them, and human cannot track efficiently around the clock. Even then they set up an alert, reaction time may be slow. That's the main reason to analyze data on the fly automatically. This set up a set of alerts based on our historical data and the set of actions our test manager should do on any event. For example, we can set up alerts for capacity test. And once one or all the limits are reached, we can stop load injection and start collecting data. There is no need to do it manually and monitor everything in real time. On the other hand, we can use a standard system monitoring in parallel and compare their observations with what an automated tool provides to improve monitoring on both sides. Let's take a look at high-level monitoring we use in our test environment. We run daemons on every server which are responsible for logs parsing, command execution, and guarding system information. All the data is transferred to a router. The router is an entry point for all data consumers. Any client can connect to the router, subscribe to a required channel, and receive only specific data. Clients can control daemons through the router, for example, by starting an extra monitor or changing its parameters. In passive mode, daemons do their job and redirect data to the router. In the example, there are two daemons on matching and monitoring server, which parse system logs and pass data to the router. Router transform data to the desired format and redirect it to clients. This is how almost all the monitoring daemons work. But we want to communicate with them. This looks like a security issue, but they are designed to work in protected network only. Clients can communicate with daemons via remote procedure calls. They can stop or start monitors, change their parameters, subscribe to real-time channels, or get snapshots of the system. Since we always disable or enable monitors, there is no need to store such messages that we only need for current test in the database. The only type of data we need to store is end-of-day logs and real-time hardware usage statistics. Once the system is stopped, we need to upload all our test results into the database. We also need to mark a particular data set as a part of some test or test step. And so we are adding text to different data sets. All internal metrics and hardware usage statistics are uploaded into the database for analysis. Because of lack of documentation and proprietary data formats, the only way to get system statistics is log data. But here we have another challenge. Most people think that logs are for human only. This is a pretty common situation, seeing a formatted table in the log or even in ASCII art. The cost of printing logs in JSON is unlikely to be higher than formatting all the data using pseudographics. Sorry, yeah. In case logs are in more or less uniform format, it doesn't mean that format will not be changed in the next release. Also, it's almost impossible to update log pattern automatically, and as a result, the tester must review similar log records and update patterns manually. Okay. There is no universal guide on how to live with it. First, it's just to accept that the fact that you are on not a client, but a test provider, and logs will change every time. Again, your opinion. Since logs are in a random format, the only way to filter them are regex patterns, which are hard to maintain and need time to match against logs. When the system under test is stopped, anyway, we find all the changes automatically, but none of all algorithms can find the exact line you need and construct a proper parser for it. Test data is sensitive, especially when we are talking about proprietary financial software, but we have to keep data somewhere, and the only place is the client server. Those servers are usually not built for such purpose, and test data is really huge, which means we can store for only a couple of weeks with detailed results. And once the time comes, we drop all but critical data such as system configurations, aggregated reports, and test records required by regulators. The test data is sensitive Yeah, the main purpose of storing data is reporting. We provide our clients with an instrument to see what will they have in production under certain conditions, inspect our tests, and discuss test results with business analysts and project managers. Here is just a simple screenshot from Graph-Analyst, the tool we use for data visualization. On the screenshot, there is a filter to show resource consumption on the host during failovers. As we can see, software testing is relentless learning. It's exploring. It is subjecting the system under test to various functional conditions under load and processing the outcomes. That's all. Any questions?
Yes, thank you very much, Ivan. For me, it was a very useful presentation and very useful story. I'm wondering, you mentioned first that to collect all those metrics, you first need to load the system, yes?
Sorry?
To run a load on the system to collect all those metrics.
Yeah.
Do you have only positive load with valid messages, or you also collect metrics running negative load?
Of course, it's two separate tests, and in both cases we need to collect metrics to be able to compare the system behavior in valid load, and in case we will inject some broken messages, for example.
Okay,
Am I
so
correct?
yes, thank you very much. And I have one more question. You mentioned this scenario in your failover test, then both servers go down. Like, in case we're speaking of the system with one component and one mirror, for example, right? If both servers go down, it's catastrophe, right? But do you think it's a QA maybe task to find a way, maybe suggest a way how to recover fast, or do you maybe record the metrics how fast the system can recover in this situation, and maybe suggest something to developers in this case?
As I understand, you're asking about how fast the system can be recovered after double failover.
Yes.
Then the system stopped to process any data.
Right.
And I believe we cannot measure this time because actually it's manual steps, and some operators should use special guide how to recover the system.
Okay, thank you very much.
Any other question? Okay, then, thank you very much.
Thank you.